Hello guys, good day. Chief Engineer Krishnan on behalf of New Age Maritime Academy. And today I want to discuss with you regarding simple automation, like how is the sensor working, how is the basic circuit, how you are getting a display in the AMS panel. Okay, for example, if you go to AMS panel, alarm monitoring system panel in ECR, when you click main seawater system, you will be seeing main seawater pump pressure and how much is the main seawater pump temperature and all. I am just taking this as an example, okay? So imagine something like this. This is the seawater line, and here you have one pressure sensor and one temperature sensor. Okay, any sensor will give output in 4 to 20 milliamps. Okay, any sensor, it will give output in 4 to 20 milliamps. So this signal, whatever the sensor output, is transmitted to SCAU, Signal Acquisition Unit. So what is the Signal Acquisition Unit basically is, there will be a analog to digital converter. Whatever is the signal coming here, these are all analog signals. The sensor 4 to milliamp signal, these are all analog signals. No? The moment I tell analog signals, it means basis on some quantity. Okay, and time is not a consideration here. This much temperature, this much pressure, these are all. It relates to analog, it relates to quantity, some amount of pressure, some amount of temperature. So what happens here, this analog signal is getting converted into digital signal. This digital signal, and one of the lines, suppose if you have suppose this is a ECR, if you have pressure gauge here, seawater pressure gauge. This is the seawater pressure gauge. This doesn't require a digital signal. Okay, so one line will directly go there to the gauge in analog signal itself. Okay, suppose this is showing 2 bar. This is showing 2 bar. This is a analog signal only. 0 to 20 4 to 20 milliamps. Okay, but imagine this as a AMS panel. AMS panel, basically monitor, AMS monitor. So here you will see 1.8 bar or whatever is the, suppose if you see more at 24 degrees C temperature. So these are all, this is what is a simple thing that is happening here. So inside AMS you will have a software. The software reads the digital signal from this output and then gives you in a digital display. Okay, that is being the software is configured for that. Okay, so you see, this is not a this is just an outline of the system. What I am trying to tell. So you must know the sensor output will be how, yet AMS feed will be should be in the form of how digital signal and analog signal, something like that. So where all the places things can go wrong, what are all faults may be happening in this system. You would have noticed the electrician telling sensor is faulty. So how he tells the sensor is faulty, he will check the continuity of the sensor, and if in case of a pressure sensor, by checking the continuity, it should show some value. This you can do with the help of the multimeter. But in case of pressure sensor, he will use pressure calibrator. In case of temperature sensor, he will use temperature calibrator to see what is the issue, whether it is showing some value or it is not giving any output. Output you can see using, there is something called digital multimeter. Using that you can see how much milliamps the sensor is giving. If there is no output, means the sensor is gone. You have to replace the sensor. Okay. So this is about just a simple outline of how the system is working. Because I was actually, when we were having tea today, my third engineer was asking me, sir, how it is coming here? It's a very good interest and initiative. These things actually, to be more honest, I am not reading and telling or something. I am, with my discussion with the electricians, I have learned something which I can share with you. And this I can tell, some more things I will cover, some more systems are there. These are all like, so that if somebody asks you, you can know little bit what to answer. This is how the thing is working. By discussing with electricians and by working with them in solving automation issues, you will learn a lot. And usually we get inexperienced electrician. That time you have to teach him, and whenever we get experienced electrician, he will teach me here and there how the things are happening. It's nothing wrong to get knowledge from somebody who is more experienced than you in all these things. So just sharing of knowledge. So see, the wiring diagrams or whatever we have on board, I know you people are in class 4 stage or class 2 stage. It is difficult for us to analyze. That's why I am putting in block diagrams, so that is for easy understanding. And whatever these junction boxes, while taking around, what we do while we take around, usually as engineers, third engineer, fourth engineer, or second engineers and all, we used to check for pipeline leaks and parameters if there is any abnormality. But in every platform you will see this SAU, DAU and all. These will be like boards. You see, this will be like, it will be written SAU with some serial number. Okay. So many SAUs are there. Signal acquisition unit. You will notice DAU, digital acquisition unit. Okay. So many are there in each and every platform in the engine room. These things, Patisabs and all will, of course, as the chief engineer, while taking around, we casually notice, okay, this is here means so many sensors are coming to this junction box and then transmitting to the AMS channel. So, as fourth engineers or third engineers and all, sometimes at that level we tend to miss these things. These are all like comes out of sheer inquisitiveness and interest. Another HMI panel example, what I want to tell is, suppose if you consider people who are working in only boiler panel. Suppose let us take an example of a boiler panel. just want to assume that this is a boiler panel or an incinerator panel. Okay, so here you have a start. Okay, we call this as HMI panel, no, human machinery interface panel. So what is happening when you press start? Suppose for incinerator, first blow a FG fan will start, then one by one you will have the sequence, no? So when you press start, okay, what is happening is you see what is in the sense there will be a processor unit. Okay, this is a computer basically. This is just a touch screen panel. So when you give start command in the panel, through the LAN cable, digital signal goes to the processor unit. This receives the signal, then this converts into this having a D to analog converter. Okay, this gives into the processor unit senses that you have given a command. Okay, see, these are all digital signals. Digital signals are basically like sound signals, light signals, and binaries with respect to time. Okay, when you touch only it will go, no. So the time when you give start, then only it will go. So I'm just giving a small example for your basic understanding what is happening. So some people will wonder, when I'm starting, how the things are happening. This is what is happening. So in the processor unit, through the LAN cable, which you know what is a LAN cable, of course, and then through the this will be near the panel. The processor unit will be at the back of the HMI panel. Okay, HMI panel, you assume it as a screen for human machinery interface. Behind that only the processor unit is there. Processor unit will be having, we used to tell card. You would have heard Batisab telling electricians, telling this card is gone. These are all like basically input-output board. Okay, these are all, suppose in your what is there in our mobile, we used to tell motherboard. All these things are similar to that. We have a processor unit. So from there, after receiving the signal, it gets converted into digital to analog signal. Okay, then it will give from this unit analog signal. This will be the form of voltage or current to the motor contactor. Just assume this is the FG flue gas fan motor of the incinerator. Okay, FG fan motor. This is the motor contactor. This will energize the contacts and initiates the motor starting. You can ask, this is how this is working. Okay, then step by step how it is starting. First you have to start the FG fan motor. Once the negative pressure comes, so then the burner will start, and accordingly the damper will open to certain amount of percentage during purging, and once the burner starts to inject, then the damper position will vary. All these things and all, how it is happening is a software will be installed in that in the processor. Basically, this is you can assume this as in the HMI panel you will have a USB port. Okay, all these things, while they are getting installed on board, they will install the sequence program. The sequence program, basically software, this will be installed at the time of when the maker sends and maker is installing the onboard installation of various machineries. Everything is a project. When you do dry dock, you will notice. When you do yard deliveries, everything they call as a project. Okay. As operators, we don't bother too much, but that is what is happening. As operators, what we need? How to run safely, how to start this, what are all the things which we need to check. Those things only we will be interested, right? But what is happening is, they come and install the software in the panel that will have a sequence system, sequence program. You one by one you have to do, and they give the software backup in the form of USB, mostly which you may find in chief engineer cabin. This not only for wherever you have a sequence program installed, they will give that for backup in case of any what will happen, all these panels, these are having UPS. So the UPS battery, you would have heard electricians replacing the battery every 5 years once. Boiler panel, incinerator panel, main engine remote control system panel, these are all having HMI and system computers. Basically you can call it as computers. These are all having UPS. So when it is nearing 5 years, before any time after four and a half years, better have spare batteries with you for your for the safety sake. Every panel will have a UPS, fire alarm panel. If you see the battery log, which you are sending every month, there you will see all these things. What I mean to tell is, suppose if the battery is gone and if there is a blackout, you will have an issues in the starting the panel. Without starting the panel, you cannot start the machinery. I hope you would have come across the present day ships where that much automations are there. You cannot start by bypassing the HMI interface. There are systems, mostly it won't allow you to start, because that is only the master control, So something like this. Another place where, that time your software backup, which they have given in USB or CD, mostly they are now giving us USBs, which you have to insert in the slot of the HMI panel. Reboot the system after installing, and then with a good battery inside. So that's how the things are in place. And regarding AMS, as I told you, suppose I hope you understood about how a seawater pressure or seawater temperature is getting, you are able to see in AMS panel and in the analog meter. I hope you have an idea about it right now. These things maybe you already know, but sometimes what happens, mostly there will be an issue with the sensor, or imagine another situation where you have a sensor. Okay, what I told before is a simple system. Now imagine one more system. Purifier system is a good example. Okay, you have a PLC and this HMI panel, okay, where you are setting the temperature, where in the purifier where you are having the start stop button, basically the HMI panel. Okay, so we call this as PLC. Just what is happening here? Suppose this is a FO purifier. This is the inlet. Okay, just assume you would have set temperature at 98 degrees at the HMI panel. Inlet temperature should be at 98 degrees or something, and low temperature alarm, all settings are inside the panel. Once you log in using your username password login, you can change the settings. And as you know very well, there are certain settings which you can't change, which may ask for admin password. Okay, I will come to that later. Suppose, imagine this is a system. Okay, this is something little different compared to what I explained before in terms of seawater pressure temperature systems. So sensors output will be the same, 4 to 20 milliamps. Okay, this is the inlet temperature. Suppose it's inlet temperature or inlet pressure or whatever. So this will give its output to, just assume this is a temperature sensor. Okay, so this will give output to the PLC. That's why while taking around, you will be able to see how much is the temperature of the fuel going inside. Okay, accordingly there is one more control system involved. Okay, for controlling the temperature, operation of steam controller. Okay, that also will come later. That also is a very simple system only. First let me finish this. Here you have AMS in ECR. This is ECR, AMS. Suppose if the inlet temperature is low, what will happen is, here there is same like this is signal acquisition unit will be there. From the PLC, here you have DAU. Okay, this will be the sensor's output will go to the purifier PLC module. From the PLC module, the signal will go to the signal acquisition unit. This also will be in terms of analog signal. This also is analog signal. This also is an analog signal. Okay, analog signal means you can imagine 4 to 20 milliamps. Okay, but here there is one more thing called DAU, data acquisition unit. Okay, what this does is, it's having lot of channels. Okay, you can call it as ports. This box is not only for one sensor. All these boxes are not only for a single sensor. You have lot of sensors feeding inside this panel. Okay, in one box you will have sensor giving the feed from the whole platform. Okay, these are all in the digital acquisition unit, DAU. Suppose if this is the port for which is connected to the SAU of related to purifier PLC. Suppose fuel oil inlet temperature low, or it has sensed fuel oil inlet temperature low. What will happen? This will give signal to the SAU as analog signal, and this will give signal to the DAU where you have NONC. Okay, so normally if the circuit is NO, that means the temperature is okay, but if the temperature has come low, this will trigger a signal. Then this will become NC. NO or NC depends on your circuit design. If you see the alarm circuit, you will know. I am just telling roughly, just an outline. So if it is NO, suppose if it is normally, imagine one of the port like this, so many feed is coming from everywhere. You can imagine these are all other alarms. Okay, here what will happen? Suppose if this feed this is for channel 43, just I am telling roughly. So what is happening is, this is actually NC. It will be in your manual, it will be written like this, NC or NO. Okay, assume NO for FO inlet temperature, FO purifier panel. So when it triggers, no, this becomes NC. That's all is happening. And once it becomes NC, this DAU will have analog to digital converter. Till now, the signals are in milliamps up to here, up to DAU. This is a DAU. Up to here, the signals are in milliamps, analog signal. And from here, it will have an analog to digital converter. From here, it will go as a digital signal to alarm monitoring system panel, and alarm monitoring system panel will give an alarm of purifier common alarm, purifier abnormal. These are all FO purifier 1 abnormal, like that as per the channel. So here you won't have the display of what is the exact alarm. Here it is only telling this knows, but this can't give like this. Okay, because the AMS software program, that is what I told you before, the AMS software, it all depends on what you programmed as per in the AMS software. Usually the programming will be for FO purifier abnormal, number 1 or number 2, whatever. This is maybe for number 1 channel, other channel maybe for number 2. Okay, just an outline I am telling. And so what will happen is, this will come as, once this becomes NC, then this will become as, this will once this has changed from NO to NC, then it will trigger a digital signal here to the AMS, telling as per the software configuration. If you have configured a software, if you, in the sense, the maker as AMS maker has configured his AMS software to tell that if this port activates, you give an alarm of here are inlet temperature low, mostly, but it will be common alarm. Then once common alarm triggers, we will go and see in the purifier panel what was the alarm, okay, which will be displayed here in the purifier. I hope you got an idea. The digital acquisition unit is where all the things are happening. Okay. During my session, in my online live session, I will share with you how this looks like. Right now I am on board, I don't have much means, so since we were these things actually in my ship, my third engineer and fourth engineer are very inquisitive regarding what I am doing. So I used to discuss with them with the same flow actually I am telling you also. So okay, I will tell you what is happening in SAU, in digital SAU and DAU and all. As DAU is signal acquisition unit, and SAU, these are all like imagine something like this where it is situated in many platforms. See, what are all happening here is, first DAU is more important because that is where more of that is the one which is giving it to the AMS. Okay, this signal is just an analog signal. Okay, this is also getting its input from all the sensors. Sensor output is the SAU input. Okay, in terms of milliamps. So what is happening? So as of now, we will see this. Suppose these are all port. Imagine as port. Usually these two ports will be spare port. This A to D converter. This AMS. So what I was trying to tell was in detail. Suppose here everything you have NC or NO or NO, NC. Just for example I am telling. Okay, channel number 22, channel 23, channel 24. Like this in serial numbers it will be there. Okay, this is, for example, this is connected to suppose channel 14. Then this should be normally, as per the circuit, it should be NO. Since it gave a SCAU triggered a signal, a digital signal, it became NC. Then it is getting converted and giving it to AMS. So what is happening? And now the interesting question is, suppose you want a new alarm to be installed in the AMS. You want to, suppose imagine that in your vessel, you have decided to, company has decided to retrofit. A best example is scrubber or BWTS or whatever. BWTS now coming with the delivered, suppose for a scrubber. So I have to have a scrubber alarm in AMS. Vessel was built in, vessel is 2015 built or 16 built or 17 built, and I am going to install, company wants to install the scrubber in 2020. How they would have done, because since I was there in the scrubber installation, I have a fair idea about what had happened, how they configured the system. I am telling in terms of alarm system, not a big, I'm going to tell you just a rough idea. Suppose I have a sensor which is giving pH alarm. Okay. In scrubber system there are so many alarms. It will be a very costly affair to put each and every alarm in the AMS panel. Usually it won't be in that way. In the AMS panel, same like our purifier, you will have a scrubber abnormal alarm. Okay, when the scrubber abnormal alarm comes, you have to go to the scrubber panel to see what kind of an alarm. Okay, scrubber mostly, suppose if you have some kind of an alarm like PAH value high, PAH high. Okay, in scrubber, when I discuss with you regarding the scrubber system, I will go in deep one by one. So suppose if you have a alarm triggered as PAH value is high, so what is happening? The water monitoring system at the scrubber wash water overboard, there is a sensor fitted. Okay, that will monitor the PAH value. So what I mean to tell is, during installation, how they are configuring a sensor with the AMS. Okay, this you can relate it to any sensor. Suppose if you want to have a alarm in an AMS, you have to have a new sensor. Sensor should be there. Suppose if in one of your ship, now to give you a more simpler example, in one of your ship you find seawater pressure sensor is there, but there is no temperature sensor. Now you want to have a temperature sensor also. Usually it will be there, but for your understanding I am telling. So what will happen? You have to have a temperature sensor. Okay, so which you will fix it in the main seawater system. This is the main seawater system. But how to give it to AMS? Up to SCAU you can connect. Okay. But the problem is, there are certain systems. Suppose if it goes to the DAU, you remember, no? There are 2 spare ports. Okay, rest other ports are already configured with the AMS. Okay, these two spare ports, suppose if it is coming like this, there are some certain areas where it has to be connected to a DAU also, any sensor, through SAU of course. So what will happen? Forget about this two, I know. It's about these are all other ports which is already there, 20, 21, 22, 23, 24. Okay. Okay. And this is, you will see, notice that these two terminals are for spare terminals. Okay. So from the sensor to SAU, you have to use the spare terminal. Okay. Up to this you can give. But now what you need to know is, now in the AMS software, you have configured only these known ports. Okay, if you see in the AMS, you will have alarm tags, no? There you will know these channel numbers and all. And there is also an option NO or NC here also in the AMS panel. Sometimes you will observe by electrician requesting to chief engineer that he wants to inhibit one alarm. There are two ways of inhibiting. Okay. One is by making, here you will have an option when you want the alarm to come, that AMS will ask, you want the alarm to come when it is in NO condition or when it is in NC condition. Suppose if as per the circuit, for example I am telling, this is channel 23, okay, this is NC as per the circuit. So when it becomes NO, you want an alarm. So as per AMS, it will be set as, just a moment.